So once again I will tell you about how we can prepare ammonia gas. Ammonia gas can be prepared by reacting an ammonium salt with an alkali. Okay, so it will give you a salt plus water and ammonia gas, not ammonium, ammonia gas. Okay. Now this ammonia gas, this is the only gas which is basic in nature. Remember, this is the only gas which is basic in nature. Okay, it is, and this ammonia gas is a polar covalent compound. Polar, and you know polar covalent compounds, they dissolve in water. Normal covalent compounds don't dissolve in water, but polar covalent compounds dissolve in water. So this is ammonium chloride, ammonium chloride NH4Cl plus KOH, potassium hydroxide, which is also called caustic potash. Which is also called caustic potash. Got it? So when you react this, it will form a salt called KCl
plus H2O
plus water plus ammonia NH3. Then the next reaction is with the sodium hydroxide NH4Cl plus NaOH. This is caustic soda. Sodium hydroxide is called caustic soda. So this will give you sodium chloride NaCl plus H2O plus NH3. And the equations are already balanced, so you need not to worry for balancing them. And the third one is, this is the first one, this is second, and this is the third one, CaOH whole twice. Calcium hydroxide, this is called your slate lime. What is this? Slate lime. Plus NH4Cl will give you CaCl2 calcium chloride plus water plus ammonia NH3. But this reaction has to be balanced. You have to put 2 over here and 2 over here. So 4 plus 3 is 7 hydrogen and 2 over here. It is balanced. Is that clear?
Yes, sir.
Have you noted now?
Yes, sir.
Please improve your handwriting, sir. Please. Abibi, you will be sent to handwriting expert. Noted?
Yes, sir.
Fine. But let me tell you one thing. The preparation of ammonia by using potassium hydroxide and sodium hydroxide is not advisable. Why? Because this potassium hydroxide and sodium hydroxide, they are highly deliquescent. You know deliquescent meaning? You know deliquescent?
The water of crystallization, that was analysis.
Deliquescent means these are the water soluble salts which when exposed to the atmosphere,
Exposed to the atmosphere
will absorb the moisture from the atmosphere and dissolve in it to form a saturated solution. Remember that. So KOH, NaOH, you studied this in 9th grade. KOH and NaOH, when you are using that, since these two are deliquescent, so they will absorb a lot of water from the atmosphere, and whatever ammonia gas is about, that will dissolve in that. So you won't be getting ammonia gas, right? Is that clear? Adya bolo. Okay? They will dissolve in water. You won't get ammonia. But this calcium hydroxide, which is also called your slate lime, this is not at all deliquescent. So we can use this for the preparation of ammonia gas. And here, so this one and this one, they are not advised, but you have to write it. Got it? Note it down. Okay. Now we are going to do the lab preparation of ammonia. We are going to do the lab preparation of ammonia. First, we will make up the setup apparatus.
Sir, banana. Sorry.
So can we turn on the fan?
This is the wire gauge. This is your tripod stand. And here is a Bunsen burner. This is your drying tower. Drying tower. And inside you have got the quick line. Quick line, which is calcium oxide, Ca. preparation of ammonia gas. Here is the mixture of calcium hydroxide and ammonium chloride. Both the powders are taken here in this tilted round bottom flask. Tilted round bottom flask. This is tilted. It is not kept in the upright position. It is tilted. Remember. So when you are heating the calcium hydroxide slaked lime and ammonium chloride is also known as sal ammoniac. Sal ammoniac. Sal ammoniac. SAL, sal ammoniac. That's the commercial name, sal ammoniac. So when these two things are heated together, it will form ammonia gas. It will form what? The reaction is CaOH. What is the reaction? NH4Cl. Already we have done that. Plus CaOH whole twice. It will form CaCl2 plus H2O plus NH3. This is going to form. But we have to balance this. 2 here, 2 here, and 2 here. Let's balance. Now in this reaction, the ammonia gas which is formed, NH3, will be directed towards this delivery tube. This gas will come along this and will get collected in this tank. The ammonia gas will get collected here. After this, the gas will escape through this, will come into the drying tower. It will come into the drying tower where we have the chuckles of calcium oxide. Yeah, quicklime. And you know that calcium oxide is hygroscopic in nature. Hygroscopic means the one which will absorb the moisture but will not dissolve. So this will absorb the moisture and will allow dry ammonia gas to escape. Now ammonia gas is quite lighter than air. Ammonia gas is lighter than air. So what will happen? It will move up. Now look here. यहाँ देखो. The ammonia gas will move up and the air which is here will be pushed downward. Will be displaced downward. So ammonia, what is the method of collection? Ammonia gas can be collected by the downward displacement of air. By the downward displacement of air. The air is displaced downward and the ammonia is getting collected at the top. Don't say ammonia, upward displacement of ammonia. No. It is the upward, that was in HCl gas, upward displacement of air. And here it is downward displacement of air. Okay. Ammonia is collected at the top. And the ammonia is displacing the air downward. So that's why the method of collection is downward displacement of air. Don't get confused. Here, we cannot use, though we have P2O5 phosphorus pentaoxide, we have conc H2SO4 concentrated sulfuric acid also. They can also be used as a drying agent, but here we can't use. Here we cannot use because we cannot use sulfuric acid as a concentrated sulfuric acid as a drying agent because ammonia is a basic gas and concentrated sulfuric is an acid. So they will react and form ammonium sulfate. This will be the reaction like if you are using like NH3 plus H2SO4, if you are, they will react. They will react and form NH4 whole twice SO4. वो भी नहीं पता है, you don't know that. Keep quiet. So 2 यहाँ लगा दो. Yeah. So this will be the salt formed. If you are so that you will not be able to collect the ammonia gas. Even if it is P2O5, P2O5 is also a drying agent only. But that also we cannot use. Why? Because it will form ammonium phosphate. It will form ammonium phosphate. NH3 whole thrice PO4. NH3 whole thrice PO4. So when ammonia will react with the P2O5, it will react. Because P2O5 is an acidic gas and ammonia is a basic gas.
Basic gas.
So base and acid they will react here. So that's why we cannot use P2O5 also. So the only drying agent which can be used here is calcium oxide. Quicklime. Okay? Done?
इसके बारे में
Now, Vachika had asked me that why are we using a tilted flask? The reason is very important from the board point of view. Very, very important, remember. You see that when the reaction is happening here, yeah, look, everyone. When the reaction is happening, what are the products formed? CaCl2, this is a salt. Calcium chloride is a salt. That will remain here only. But this one and this one, they are going to come out. The water vapor, the water will come in the form of vapor. And this is a gas. So the both will come out. Had the flask been in the upright position, agar ऐसे, had it been in the upright position, in the vertical position, then the water vapor, when it will come in contact with the cooler part of the flask, when the water vapor will come in the
contact with the
when it will come in the contact with the cooler part of the flask, the water vapor will condense. The water vapor will and will start trickling down and will trickle down.
fall down.
Trickle means coming slowly along with the wall of the flask. Like this. Got it? So when it will trickle down and will come in the contact with the hotter part of the flask is likely to break. Flask is likely to. Again, there is a little mixture of physics. I'll tell you why the flask crack. Because when the cold water is coming to the hotter part, due to the uneven expansion of the glass, when it will be coming, cold water will come, that part will contract, but it's already heated in the expanded form. So due to uneven expansion, the flask will crack. Is that clear? So that's the reason that the flask will crack. In order to avoid that breaking of the flask, we are keeping the flask in the tilted position. So we'll write that one also. So, method of collection.
Downward displacement of air. So upward.
Displacement of water because it is a highly soluble gas. Is that clear? You cannot collect ammonia gas by the downward displacement water because ammonia gas is highly soluble in water. I'll tell you one thing, it's around 1.7 times faster than HCl gas. It dissolves nearly 700 something liters, 700 and something liters of ammonia gas will dissolve in 1 liter of water. And HCl was how much? 452 liters. 452 liters of HCl will dissolve in 1 liter of water. Whereas ammonia is nearly 700 something liters will dissolve in 1 liter of water. So even ammonia is much more, soluble, highly soluble in water. Is that clear? Now the identification. Identification of ammonia. Ammonia gas is prepared. How will you come to know that there is ammonia gas formed? So what do? Bring a moist red litmus paper and bring it near to the mouth of the gas jar. It will turn to blue. If you bring a moist red litmus paper and bring it near to the mouth of the gas jar, it will turn to blue. This shows that ammonia is basic in nature. This shows that ammonia gas is basic in nature. Then another thing, bring a glass rod dipped in concentrated hydrochloric acid and bring near to the gas jar. It will produce dense white fumes. It will produce. We did in HCl also, but there we put the glass rod dipped in aqueous ammonia. We dip the glass rod in aqueous ammonia, and here we are dipping in
HCl.
concentrated hydrochloric acid, and then bring. You are getting the dense white fumes of what?
HCl. So we dipping it and concentrating.
It will form the dense white fumes of ammonium chloride, NH4Cl. Ammonium chloride का dense white fumes you will get, which will further sublime, वो solid हो जाएगा. It will deposit on the walls of the test tube or whatever. समझ गया ना flask. So that is your test. Another test is like if you pass ammonia gas through say ferrous sulfate solution, it will form a dirty green precipitate. If you pass ammonia gas through lead nitrate solution, it will form a heavy white precipitate of lead hydroxide. Got it?
Yes, sir.
And if you pass ammonia gas through copper sulfate solution, it will form first it will form pale blue PPT, and then in excess it will become an inky blue solution. Inky blue, transparent blue colored solution will be formed. Is that clear?
Yes.
So let's write that.
Sir, physical properties भी होंगी ना?
One more topic that this was the lab preparation we have done. There is one more way that how we can prepare ammonia gas. That is second method. Ammonia gas, write down this one also. Ammonia gas can also be prepared by reacting metal nitrides with hot water. hydroxide and ammonia gas. So the first one, Mg3N2 magnesium nitride, when it will be reacted with the hot water, it will form magnesium hydroxide MgOH whole twice plus NH3. Now you have to balance it. For balancing, you just need to put 3 over here and 2 over here and 6 over here. That's it. Then there's another one is Ca3 calcium nitride Ca3N2 plus H2O, same thing, arrow 3 CaOH whole twice plus 2 NH3. And the third one is aluminum nitride ALN plus H2O will give you aluminum hydroxide ALOH whole thrice, aluminum hydroxide plus ammonia.
सर बालचिंग सेम नहीं होगी.
Why is balancing same? Because aluminum, nitrogen, they both have the same valence of 3. So why would be the same? It's ALN. It was not. Go fast. Note it down. We'll be doing the identification of ammonia, right? So I have told you all the 3 tests. it will turn into inky blue solution. So these are some of the conformity tests for the ammonia gas. It will confirm that the gas produced is